Okay, let's continue our discussion. We have example 7.8 here. A 400 kg satellite is under a circular orbit of radius 2 RE. So let's say here we have the Earth and here we have a satellite, and this distance from the center of the Earth, and this is its orbital path, and this distance is 2 RE, where RE is the radius of the Earth. Okay. How much energy is required to transfer it to a circular orbit of radius 4 RE? So it has been moved from here to a new position. So let's say it has been moved to a new radius here. Now it is revolving in a circular orbit and the radius of the orbit is 4R. So this is its new orbit. Okay. Now what we have to do, we have to find out what are the changes in the kinetic energy and potential energy, and also we have to find out how much energy is required to transfer it to a new orbit. So let's say this is its initial position, means initial orbit, and this is its final orbit. So in case of initial orbit, it has potential energy, and potential energy can be given as minus g mass of the Earth into mass of the satellite divided by r, and r is 2re. So here it is 2re. Now, what is its kinetic energy? So kinetic energy is g me ms by twice of the orbital radius. So this will be 2re, and ultimately it is g me mass of the satellite, and then it will be 4re. And then what will be the total energy in this case? So total energy in initial situation will be kinetic energy plus potential energy. And look, Gme ms by Re is common, so we can take Gme ms by Re is common, and then we have for kinetic energy it is 1 by 4, and for potential energy we have 1 by 2 here. And this will be minus Gme ms by 4 Re. This is the total initial energy. Let's say it is initial energy. Now we can put the numerical values here and then we can get. So we can do a smart thing here. Gme ms by 4 Re square and then into Re. So I have multiplied by Re both in denominator and in numerator part. So it will be minus 1 by 4, and look, Gme by Re square is nothing but acceleration due to gravity, and then ms into Re. And now we can put all these values. Minus 1 by 4, let's say this is 9.8, and then ms is given 400 kg. Look, this is energy. So at the end, it will be in joule. And the radius of the Earth is 6.37 into 10 to the power 6 meter. So now we have to solve this part only. Minus 9.8 into, look, this 4 and this is 400, so it will be 100, and then 6.37 into 10 to the power 6 joule, and further we can write minus 9.8 into 6.37 into 10 to the power 8 joule, and then it will be minus 62.4, and let's write it to here, and then it will be 10 to the power 8 joule, or we can write minus 6.24 into 10 to the power 9 joule. So this is its initial energy, and we have solved for initial potential energy and initial kinetic energy. So let me write it here. Initial potential energy, initial kinetic energy. Now we have to calculate for the new orbit. So the orbital radius is 4 RE. So everything will be there. Here we will have the new or the final kind potential energy minus G ME MS by this will be 4 RE now. And here we have final kinetic energy G ME MS by 8 twice of 4 RE means 8 RE. And then final energy will be minus G ME MS by 8 RE. Now, look, we have already solved for this thing here. Look, minus G ME MS by 4 RE, we have obtained this much. So, this is nothing but half of this value. So, the final total energy is, let's say EF, is half of this value, means this is 1 by 2 of initial total energy, and it will be uh, minus 3.12 into 10 to the power 9 joule. Look, these values are approximated one. Okay, so final energy is here and initial energy is here. You can easily obtain what is the change in energy. So let's say if the change in energy is delta E, that is final energy minus initial energy, and then you will have minus 3.12 into 10 to the power 9, and of minus of this thing will be plus, so 6.24 into 10 to the power 9, this much joule. Or we can write simply, it will be 3.12 into 10 to the power 9 joule. So its final energy is more than its initial energy. That means this much energy has been supplied to the satellite so that it can go to a higher orbit. Okay, again we have to find out difference of kinetic energy and potential energy. So look, this is final potential energy and this is initial potential energy. So we can do what is the difference of potential energy. We can write change in potential energy can be given as potential energy final minus potential energy initial. And we know final potential energy G ME MS by 4 RE and negative of this thing. And minus G ME MS by 2 RE. This is initial potential energy. Here you will have G ME MS by RE, which is common. And from here you will get 1 by 2, and from here you will get minus 1 by 4. So ultimately it will be G ME MS by 4 RE, and we have obtained this value already here. So it will be 6.24 into 10 to the power 9 joule. Look what is happening here. Here we have obtained minus GME MS by 4 RE. So it was coming minus of this value. So if we are going to do GME MS by 4 RE, it will be positive, this much positive value. So this is the change in potential energy, means potential energy is also being increased. So we can write change in potential energy. Now what about kinetic energy? So let's check what is the final kinetic energy and what is the initial kinetic energy. So final kinetic energy minus initial kinetic energy will be K final minus K initial will be G ME MS by 8 RE minus G ME MS by 4 RE. This will be G ME MS by 8 RE and negative of this thing. I hope you can solve for this value here. And now, what is the look again here? GMEMS by 4 RE, we have obtained this much, and GMEMS by 8 RE will be half of this value. So again, this is 1 by 2 of this value, and with negative sign, so it will be 3.12 into 10 to the power 9 joule. Now, We have change in potential energy, change in kinetic energy, and change in total energy or the energy provided to the satellite to revolve in a new or higher orbit. So these are the questions we had to solve. So this is all for this video. In the next video, we will start solving previous year problems from your NEET exam.